All right. Let's get started. Where is Tina, can you connect on Zoom? Just make sure that you see this. Yes, all clear. Perfect. Thank you, Owen. All right, let's get started with today's lecture. It's gonna be Python lab. So it's kind of like an lecture. I'll be doing some Python stuff because for this homework, you don't need to use Python. Actually, for any of your homeworks, if you want to do it in MATLAB, you are free to do it in MATLAB. But there's a big but here is that all the code that I provide for getting you started with the homework is gonna be Python. So I would say it's much more convenient to just edit on top of what I put than trying to recode whatever I put on Python into MATLAB. For this first homework, actually makes no difference because it's very simple. It's really just solving the linear system of equations. But for the future, I will provide Python code. I think it's okay to do it in MATLAB, but I would encourage to do Python since it will save you some time. This should already be in the Brightspace. I didn't check, but this is what I had from last time I taught it. But I'm going to start from scratch just to do it as I go, and I will just check back to make sure that I cover all the things that I had on this Python Lab 1 complete. I have Python installed locally. So I have this Anaconda Python distribution. You don't have to install Python locally if you don't want to. You can use the Google Colab. Really, you just need to Google Colab, and then yes, it will go to something like this. And then you can always just do a new notebook. You can also upload notebooks. So for example, for my starter code, you can download that and upload it to the Google Colab. This runs in the cloud, so you don't have to have anything installed. The only downside of the Colab is for files. So some of the homeworks will require you to read a text file with the mesh information. And I'm not sure how you can do it in a way that does not require you to, every time you want to run it, you have to upload the file. I think the Python file gets saved in your drive, in your Google Drive, but I think the other files, like a text file with a mesh, I think you have to upload that every time. I'm not completely sure about that. Shouldn't be too bad either. And it's the exact same functionality, and it runs pretty much the same speed. So either way should be fine. Otherwise, if you have a local Python distribution like Anaconda, you can run this Jupyter, and that's the same notebook. So if I create a new notebook here, it will look like this, and it really has the same functionality as the Google Colab one. Let me just call this PL1 in class. So the first thing for Python, how do I get rid of this? The first thing for Python is, unlike MATLAB, you have to import a bunch of the libraries that you want to use. So for most of the things that we're going to use are in this library called numpy. So you have to import it. So import numpy. You can import all the functions of a library and then just use them. Very typical, especially if you Google something, how do I do something in Python? It will have import numpy as np. This is completely arbitrary. It's just a short. Can I make this bigger? It's just a short. You'll see, because now every function that you want to call out of this library, you need to use numpy dot the name of the function. I just say that. So if you do something like that, then let's say that the sine function, you want to use the sine function, which is in numpy. you would have to do something like that. So np dot sine of, I don't know, and this is in radians. So let's just do np dot pi, comma 2. So for example, you do something like that, you have to use np dot every time. If there is some function, and the reason why this is done, not just in Python, but in many of the programming languages that are more general, unlike MATLAB or Java, C++, etc., you want to have the functions associated with a particular library, just to avoid overriding functions or naming two functions the same, but that are used in two different contexts. But if there's no risk of that, you can explicitly import. You can either do from numpy import star, and that would import all the functions of numpy. And so if you do that, then you can use the sign without the np. So then you can use, I don't know if it imports the variables. It definitely, yes. So now you can use sine of pi over 2, for instance. So you don't have to use the numpy. Convenient, I almost always do the import numpy as np, and then you'll see a bunch of np dot throughout my code. And that's just because I guess that's technically the best way to ensure that you don't conflict with any other functions from other libraries. And that's what you will find most commonly. If you just Google anything how to do in Python, you will find that structure: import numpy as np, and then np dot a bunch of things. Yes.
I know that in MATLAB, if you try to override an existing function, it gives you a warning.
Oh, here it won't.
It won't.
That's why that's exactly the reason why if you just Google it, you will see import numpy as np and np dot, because if you define another sign function, it will override it. So if I do def sign of x, by the way, this is how to define functions, which was another. Comments are with the pound sign. So you will see that it has no problem with you doing this. So return is what you need to do for returning something. Let's do that. So I just read in shift enter, or typically to go to cell by cell is shift enter. So shift enter to run a single cell, and then def and return to define a function. I will also upload this one. The one that says PL1 complete has better comments. While I'm doing it in class, I'm obviously just saying a lot and then kind of commenting. The other thing that I wanted to say was indentation is super important. So you will notice that the def is completely left indented, but in Python, there's no end keyword. Everything works with indentation. So in MATLAB, for example, you have a for and you have an end, or you have a while and an end. So there's always something that tells you where a particular chunk of code ends. I mean, you explicitly write end. Here, it all works with the indentation. So if I go back here, I will need to, and this is automatically doing it. So anything here, for example, a equals 2, which is like standard MATLAB type of thing, has to be left indented. I cannot do something like this, it will complain. So if I hit shift enter, it will say bad indentation. Like I did not expect it to indent because there's no for, there's no if. So this will not go well. Yeah, so now we redefined sign, and let me just call sign of, let's say, still pi over 2. So I'm gonna call sign of pi over 2, which should be 1, but now it's 0. So 10 to the minus 17 is 0, which is clearly wrong. And that's because I just redefined sign. So it will not throw an error. However, the NP function is still correct. So the NP dot sign, that one I cannot redefine. Then it will not let me. So I cannot redefine this function. This one is still correct. So NP dot sign is still correct. And that's the reason why now I need to clean my mess. So well, now this doesn't work. I should do NP dot sign. There we go. Okay, so now that should be correct. I just redefined. Yes, so now I fixed my mistake, but that's why you will see a lot of times that you keep using the NP. You had a question?
Yeah, so like I know in MATLAB, the text files that it saves it to will end with .m. What does this end with?
Yes, so IPython notebook, which is IPYNB. You can export it as PDF from the Colab or even from a local Python, or you can export it as Python, so .py. You can export it as HTML. I think you can export it as a bunch of things, but the native file format is Python notebook, which IPYNB. Other questions? All right, so the basics ones are variable assignment, just same as MATLAB, you know, like A equals 2, B equals A plus 2, like that type of thing works exactly the same. You can reassign a variable. That works exactly the same. So I'm not gonna cover that. The other one is function definition. That one I just did. So it's just def and then the name of your function, my function. And then you say, for example, it takes X and then it does something to the X, like let's say Y equals X plus 2, and then return Y, for example. Again, remember the indent, that one is a little bit different from MATLAB. And then for loops, you need for, and then this one is a little bit different. So this one will use a very specific, so this is very typically what you will find. So for I in range 10, that will just loop I between 0 and 10 and just print I. So if I hit shift enter, what I should see is 0, 1, 2, 3 for up to 9. A couple of things. So range creates a list from 0 to 9. Index this one is a very, very, very different thing. So here, for loops always start from 0. Unlike MATLAB. MATLAB has everything from 1. So all the indexing in MATLAB is from 1. All the indexing in Python is from 0. You have to be super careful about that. What else did I have in my Python complete notebook? So variables if I need the if. Okay, so this is for loops. Let me do if statements. So if and then something, I don't know. What variable do I have defined? I have defined b. If b less than 2 colon. Also, most of the function definition for if use colon. So you should have the def, for example, I have def something colon and then the chunk of the code that defines the function. For the for loop, also for I in range and then colon to denote the start of the for loop. For the if statement as well. So for if b less than 2, maybe I should do another one, which is that say, so if b less than 2 or b, I don't know, or so you explicitly say or and. Then I don't know, print b. Here, that's it. There's else statement. You also need a, and then you can do something like that. So if else statements look like this. So in this case, it was greater than 0, so it just printed b. But if I change, I'll just change. So this makes sense. I'll just change it a little bit. So, but if I ask for an and, so in this case, this should be b was not between 0 and 1. So in this case, the condition b has to be less than 2 and greater than 0. Actually, it can only be somewhere between 0 and 2. Sorry, 0 and 2. So in this case, it will go to the else statement. So if this is not true, so it will not do that, else it will do this. So b was not between 0 and 2, b was 6. Okay, so that takes care of if, for else statements, function definitions, basic function assignment, and numpy. So variables if for functions. There's more examples in the notebook. For loop, function, function. Okay, arrays. There we go. Any questions up to this point? Cool. So let's go to the actual linear algebra part. Some differences between Python and MATLAB. Here you have to explicitly call the array functions. So in MATLAB, you can just say A equals and then start using brackets or parentheses to define a matrix. Here you actually have to say array. You have, I'll show you in 1 sec, but you have to explicitly use the word array. The other one is square brackets instead of really, I thought MATLAB was with round brackets.
It's like a function.
Oh.
You're just defining something square,
Oh.
right?
Even to access like an array, you do the, okay, then I stand corrected. What else? There are a couple of functions that are similar to MATLAB. So same as before, let's just define some matrix A. Again, like I said, we have to use the word array. In most cases, you will see np.array. And then you can define, for example, let's say, and it's a nested square brackets, like 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9. So this is a 3 by 3 matrix where the first row is 1, 2, 3. So that all is within one set of square brackets, then comma, the second row is 4, 5, 6, and the third row is 7, 8, 9. So if I just print that, it will print in the by row. So 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, you can skip the NP array because we have imported all the functions. But again, the only risk with doing this is that if you redefine the array functions, then you're done. So mostly you will see, if you just Google anything, you will see the NP just all over the place. Okay, so that defines, there's a few easy ways of defining functions. For example, there's a zeros function, which is very similar to the MATLAB one. For example, a zeros 3,3 matrix will just create a 3,3 matrix full of zeros. These don't have to be square. You can say, let's make a 3 by 4 matrix that is full of zeros. So we create a 3 by 4 matrix that is full of zeros. There's a ones function as well. So you can say, I want NP ones of whatever dimension you want, like 5,2. So this will create a ones matrix of ones, dimensions 5,2. Those are the main ones. There's no clear distinction between arrays. Both are treated as arrays. Just that one is one-dimensional and the other is two-dimensional. So a vector, let's call this lowercase b, would be, let's say, 2 ways. You can either just do 1, 2, 3, for example. This would be a vector. And it looks the same. You still use the word array. And the only reason why it's a vector is because it only has one dimension. It's not a matrix, but they are both dealt with the same keyword. So there's no two different objects for matrices versus arrays. Yes, what else do I have? Okay, so that defines matrices and arrays, and then basic linear algebra operations. But what's your favorite linear algebra operation?
That's the one.
No favorites. Okay, matrix multiplication. All of this is used with dot. So the NP dot function is basically either for matrix or matrix vector multiplication. So for example, B is a array of dimensions, either 1,3 or 3,1. It doesn't really matter, but we're gonna assign it to, I don't know, lowercase c is gonna be NP dot of the matrix times the vector. So let's do A, B. This one will be valid because A is 3 by 3 and B is 3 by 1. So if I do this, so this one is valid. So this is what comes out of multiplying matrix A, which was a 3 by 3 matrix by vector B, will give you that. But the same function can be used to multiply matrices. So let's call another matrix F NP dot of A, B. So both A and B, actually, this might throw me an error because actually this will work. This will work because A is 3 by 3 and B is 3 by 4. So this should work and it should be a matrix of zeros. And the dimension should be also 3 by 4 because the standard matrix multiplication. So it will contract the middle index. So this will be fine. Yeah, so it's just a 3 by 4 matrix with zeros. I'm multiplying by, let me just change B so that it's not as boring. And then I can also tell you the area assignment of a matrix. So if you want to change, for example, we want to change B, which is full of zeros, you can just access the corresponding entry that you want to change. So let's say that we want to change the first entry. I will just say, remember index starts from 0. So if I want to change in B, I want to change the first entry. That's the entry 0, 0. So here B 0, 0, I'm going to change that to say 2. And I'm going to change the entry 1, 1, so kind of the diagonal. Let me change that to 3. And the entry 2, 2 is going to be 4. I keep on using. I swear my password is not 1, 2, 3, 4, 5. So now if I do that, I just print B. So you see how I changed the first entry, then so diagonally. Then I'm printing F. I should be printing F. All right. So now you see how I've changed the first entry of B, then the diagonal. I didn't do anything to the last column, still zeros. And F, this is the multiplication of A times B. Like I said, this works because A is 3 by 3, B is 3 by 4. So this is well defined. Okay, so matrix multiplication, matrix vector multiplication. Vector multiplication also uses the same so for example, let me call this little f is going to be np dot. I have two vectors, B and C are both vectors. So the dot can also be used to get the dot product between two vectors. So in this case, these two 3 by 1 vectors, the dot product is some scalar. So the scalar is 228. And the last one operation that I want to define is the solution of linear systems. There's no backslash. You have to use np solve. np solve is basically the equivalent of the backslash. So we have to do, and then np solve, and then matrix, comma, vector. So if you have the equation, let's say that we have ax equals b. That's the equation that we want to solve. Then we want basically solve a comma b. That's basically what we want. So if you have a linear system of the form ax equals b, in MATLAB you would do a backslash b. Here you do np solve a comma b. So x equals np solve a comma b. Again, A is this 3 by 3 matrix, B is this 3 by 1 vector. If I do this np solve, X is going to be a 3 by 1 vector, which has the solution of this linear system. Now, before I do this, is this going to work or not? I think it should work. Unless if the matrix is singular, it won't work. But if the matrix is not singular, it has no attribute solve. Wait, what? It should have a solve. Oh, it's linear algebra. Okay, so sorry, it's linear algebra dot solve. Linalg dot solve. Okay, yes. So the error is different. So the change this here. Again, if you don't want to do np.lineage.solve, you can always do import np.lineage.solve as solve, for example. So if I do that, it will just rename this whole thing, this np.lineage.solve. It will just rename it to solve. So if I do that, no more np. Oh, sorry, this has to be here. I cannot do the, because I have to do from numpy.lineage. So this work. Okay, that works. From numpy import. Then I can just use solve. The error is different though. The error is because A is singular, because it's made as 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's just multiples of the same thing. Matrix is singular, it won't solve it. But let's just make a no. Let's just edit so that it's not singular. So let's change the 1 entry to be 1, and let's change the 2 entry to be 2. I think that should take care of things. Anyway, just something so that they are not multiples of each other. Any questions? Yes.
Why did you say 1 dot and 2 dot?
You don't have to. In previous versions of Python, if you don't do the dot, it will treat it as an integer. And then the problem with that, now it doesn't do it. But before, let's say you do something like 1,2. In Python 2, this used to be 0, because it would treat it, it would basically say, this is an integer, this is an integer. But now it treats them by default as a float. I think MATLAB, regardless, it will treat it default as float. Double, yeah. Yeah, so before this would have thrown 0. They've changed that, but I'm so used to the to not have errors, and then it would be difficult to debug, because then if you have a 0 somewhere that you just didn't know that it does look like it's wrong, but you would get a 0. So I use the dot to basically, this tells Python that for sure it's a float, but you don't have to anymore. You can just do 1, 2, and it will be fine. Other questions? No. All right, so mostly everybody has a computer. Otherwise, if you want to pair up with someone that has a computer, and so that I'm not the only one speaking, I'll give you 5 minutes to go over what we were doing last time in class, and then try to get the matrices of the linear system that we were defining at the end of last class. So if you take your notes from last class, we had this 3x3 system. So if you can just define that, and then maybe try to solve it. Basically, just try to get the matrix, get the vector, and then try to see if you can get it to solve, and then I'll do it. Just assign random variables. I don't think I gave a number for the k. Just say k equals 1, for example. You remember what it was. Yes.
Right. So I have a file like this.
Yeah, so open the Google Colab.
Oh, I actually installed the app on the.
Oh, you should have something called an Anaconda Navigator, so there must be in the, like, your style, not there, but in like, yeah, it should be, there's a.
I think it was,
Oh, yeah, so then,
so I have to launch it from the terminal.
and then just click on the Jupyter, you probably, yeah, launch. And this will look like exactly what I had, and then just go to whatever folder you will save the.
Oh, so this is local, this is not on.
It is not in it. Actually, I would create a new one, because if you try to load what you were just following, if you just save it as IPV, it won't recognize it. So if you open the IPV file, it has a bunch of headers that tell it a lot of restrictions. So you won't be able to open it up.
Did you say the
Just create a new one. But yeah,
Like
go to
this
your prepared folder.
or you know which one I'm saying?
You can just choose which one. These are all the same, right?
Okay.
Essentially, they're the same.
But,
But I think we need to do.
Yeah, because if you click on this one, it will throw an error. I mean, you can click on it, and then you will throw an error that say, I don't recognize this. It doesn't have all the headers. So just create a new one. Yeah, 5 and 3. And yeah, this looks exactly like what I was doing. Yeah. Import numpy as NP. Import numpy as NP. Yeah, I mean, the NP is everything. It's just what you will find in your Google, anything numpy. Import numpy.
NP dot sign.
Yeah, NP dot sign, and then there's some numbers. Yeah. Yeah. Assign it to something. Yeah. Right. Yeah, exactly. Shift enter. Yeah, and there you go. So that's the sign of 3 radians. It's in radians. I think it is, it automatically says, but it's not like every second. I don't know exactly how frequent, but frequently, it says frequent.
Okay, so what if I, okay, so I can't, run this from the terminal, I have to run it from the.
Correct, yes. Yeah, to run from the terminal, you would have to run a Python script, so .py. I like the notebook, but
If you want to run it, you can run it sort of like on a comment, it's the same thing. You just need to go to that folder. Python, go like the name dot py on it, but this is a lot easier to be done.
So on this, if I work with enough terminal and this point, so it's in this directory, if I wanted to run this. From the terminal, is that?
No, you don't run the Python notebook from the terminal. You run, if you open up this file, you can download it as like a Python file, the .py one. You can run that through here, and to run that, you just do Python space, whatever you want. The name .py.
So in this thing, if I want to download it.
And then download this. And then there's a couple different ones. The PY one was the one that.
yes.
Now.
Either of two things. You either rewrite one of the equations. You have to replace variables and it's limits.
Not useful.
It's actually used a lot more in the supercomputers. Most of the stuff you're doing for like calculations that are not run on our own laptop, we run it similar to you. Their system use Linux, basically the same as like. Not exactly.
I'm the kind of nerd that likes running Linux natively on my laptop. If I have to open up Microsoft Office or something else, I run it on a virtual machine.
Yeah, no.
I guess. This is more on figuring out what we can. My battery is any of it full, that's fine. I have a previous laptop. I don't remember. One bit, simplicity on average, one bit every 4 days. So, that's like, I've never seen every, on average, every 4 gigabytes of data that is go through RAM, one bit, which. That's a million dollars. Yeah. I would. You would never know when it happened. Yeah. Have you ever watched seen a video that erupted where everything's playing normally and all of a sudden weird back place? Yeah. Oh yeah. See how far we get, but instead of just random video being it's simply so this frame will increase. Yeah. It's your yeah. It would just think it all. Yeah, exactly. Most important words, every 1 to 3 seconds, 2 frames, it's a brand new old frame. It's not also everything. That way, if we skip around and we don't know in the video, there's still no most of the video go backwards to find the nearest key and rebuild and stuff. So it makes several fun times. Yeah, because I know a little bit about like and there well, I think I'm uploading all the videos. There's one on six. Yeah.
Well, yeah, on the
Well, I think it's because I'm loading every photo, all the videos are
facing more chunk of video.
I think it's okay. They want the video. I think it all depends on whether they do what. Or that, yeah.
Then if you have 1 day, second day.
So basically, how and have you ever seen it where somebody moves their head and in the background, the wall behind them moves with them because the entire video is so compressed that it's approximate everyone.
They do. All right.
You guys also like reserve for like the weeks and stuff too, because you can use that as an alternate.
All right. All right, let's solve the example from last class. I'll just do it fairly quickly. I saw a few of you. All you need these values that I didn't give, but I saw someone doing this. So I'm just gonna copy that. So 1, 2, 3. And then the K matrix was bracket, bracket. And then I think the first one was K3, maybe. I don't know. I have it open here. So K1 plus K1. Sorry, K1 plus K2. So K1 plus K2, if I have the correct example, then 0, then minus K2 minus K1. Then the second row was 0, K3, and minus K3. And then the third row was minus K1 minus K2, then minus K3, and then K3 plus K1 plus K2. Right, this is what I had for my global stiffness matrix. So this is K. And then the force vector was MP array. For the first one, I actually don't know the force. So it's just, it should have a reaction. I'm going to put 0. And then the second one, I also don't know. And then the third one had a force of 5. So that was the force vector. And now how do I solve this? Because here, if I just cannot do this here, but the KU equals F, right? But here, well, F plus R. And here, this is where the boundary conditions are important. Dealing with boundary conditions, because the first two, I don't have any external force, but I actually have unknown reactions. So if you were to write out the entire linear system, I have only one unknown in the U, and I have two unknowns here on the R. So there's two options to do here. One option is to replace the first two equations with trivial equations. And the other option is matrix partitioning. I'll do second option first. So for the second option, I need to get the matrices KE, and this will introduce, I'll do the second one because I only have 2 minutes, and this one is the quickest. KE is the part of the matrix that is at the beginning between, let me just call number of boundary conditions. There's 2 nodes with boundary conditions. So this colon thing, this 0 colon NBC, what it will do is it will take all the rows from 0 to NBC and all the columns from 0 to NBC. So if I do that, you will see that KE, no, I'm gonna run out of time, but you'll see where did I do wrong. This should be N underscore BC. You'll see that this took out this little submatrix, like just the top left corner. So similarly, you can do KEF. That one was, if you go back to my drawings, that one was the rows from MBC to the end. For the end, you can either do 3 or you can do -1. -1 also denotes the end. And then the columns was 0 to NBC. So this will take this lower, it's just a number, but it's going to be this lower left. And then KF was K from NBC to the end. So this is the top right corner, and NBC to the end. And then I need to wrap it up. NBC, why is this not correct? Let me delete this. I thought -1 should work, but it's not. Oh, so it should not be -1. Sure, I'll double check that because but if you just leave it open, otherwise you had to be 3. 3 is the actual size of this should also work. Yeah. So either do nothing or put the actual size of the matrix. And so you can see that these are the different matrices. And then I'll just finish and then we go. I'm already late. So the displacement F, so UF was MP, well, I just have solve. And what was the matrix? The matrix was KF minus KF dot. So here you have to do dot KF times UE. I also need the vector UE. Let me put that here. Vector UE are the known displacements. So the known displacements, which I know are 0, 0, and then UF is just solve that, comma, and then forces. I also need FF, that is just F MBC to the end. I'll upload this. But that's basically in code what I wrote last time. So split the matrix into sub-matrices, and then then the solution is really simple. So you can do that for your homework. All you need to be careful with is the partitioning, but sounds good. All right, see you on Monday. I'll upload this, and there's the complete one already.